Good morning. All right, so we're going to jump back into chapter 3 now. This is 3.5, complex zeros. So remember we talked about complex numbers last time in 1.6, and so now we're going to be able to use those complex numbers to find all the possible zeros of these polynomials, right? So before we were just looking at the rational and irrational real zeros of polynomials. Now we can say, well, we could actually have some that are complex, and so now we can find them all, right? Continue to work on homework, right? Let me know if you have questions on that for sure. Again, I'll adjust the due date as we need to as we get into next week, but at least try to be working on that through the weekend, because you'll actually have a lot of what you need for the first part of that homework, and then we'll finish up 3.6 and 3.7 next week, okay? Any questions, comments, concerns before we get started today? All right, so like I said, we're going to look at complex zeros, and we'll get to the fundamental theorem of algebra and what that actually tells us. Okay, so starting right off the bat, fundamental theorem of algebra. So every polynomial, and this is that same form of a polynomial we've been looking at here, with complex coefficients has at least one complex zero. Okay, so right now, all we know for sure is that this polynomial is going to have one zero that's complex. But remember we said yesterday, complex numbers include real numbers, right? So like the number 7 is a complex number. It just only has a real part, and its imaginary part would be 0. And so all we're saying here is that if it has complex coefficients, there's at least one complex 0 of that polynomial. Now, what we're going to use that for, though, is to take that polynomial and we can actually factor it down to all of its factors where these c values now are complex numbers. Okay, so we can get it down to linear factors, meaning x to the first power, where these c1, c2, and so on are all complex numbers. Again, they could be real numbers because those are part of the complex numbers, but they could also be imaginary now. Okay, so that's what we're going to be looking at, is how do we get all these factors, including any real zeros and any imaginary zeros. All right, so let's start here with this one. We want to find all the zeros of p, and we've got x cubed minus 3x squared plus x minus 3 as our polynomial this time. All right, so thinking back to 3.4, right, when we were looking for all the zeros, what's the first thing we might want to try with this one? Okay, good. And so to do the synthetic division, though, we have to know what first? Okay, good. So we're going to look at our p and q values, right? Figure out the p's over q's, figure out those possible zeros, and then we'll do our synthetic division to see which ones work. All right, so let's start with our p values here. So what are the values of p going to give us? Good, 1 and 3, right? Because we're looking at the factors of our constant term, which is 3. Remember, this is always going to be plus or minus, so plus or minus 1 and plus or minus 3 are the factors of negative 3. Now let's look at the q values. Okay, what are the values of q going to be? Good, just plus or minus 1, because here we're looking at the leading coefficient. That's an understood 1 this time, so the only factors are positive and negative 1. Now we divide. When we do p over q, what are the values of p over q going to be? Yeah, just 1 and 3, positive and negative, right? Because we're dividing 1 by 1, which is still 1. 3 divided by 1, still 3. So we get plus or minus 1 and plus or minus 3, right? Same as the list of p-values, because we're just dividing by 1 this time. Any questions about finding the p over q values? Okay, now once we have those, what are we going to do next? Okay, good. So we got to pick one for synthetic division. How are we going to choose which one we want to start with? Yeah, we could look at our graph to see where it looks like the x-intercept is, right? So let's go ahead and look at Desmos. Look at this graph. That'll tell us which one we might want to test using our synthetic division now. So we got x cubed minus 3x squared plus x minus 3. So looking at that graph now, what value might we want to test first? It looks like positive 3, right? So that's the only place I see where it crosses. So let's go with that one and we'll see what happens. Okay, so I'm going to test positive 3 here using my synthetic division. So now we need our coefficients. This time we're not missing any terms, so it's just going to be positive 1, negative 3, positive 1, negative 3. Our first step here for synthetic division, remember, bring down the 1, and then we multiply. 1 times 3 is going to give us 3. Now we add. Negative 3 plus 3 should give us 0. 0 times 3, 0. 1 plus 0 is going to be 1. 1 times 3 is 3. And then negative 3 plus 3 is 0. So what does that tell us then? Okay, good. 3 is one of our zeros now, right? So if we were looking for the zeros of this polynomial, 3 is one of those zeros. All right, now, what can we do at that point? Okay, it's good. So what factors do we have now based off of what we've got so far? Okay, so x minus 3 has to be a factor, right? So I'm going to come down here since we're looking for the factorization on this next step. X minus 3 is a factor. And what else is going to be a factor? Right, so this line right down here now, the 1, 0, 1, is going to be x squared and plus 1. So the 0 represents the x term, so there is no x term this time. So it's just going to be 1x squared plus 1. Any questions about how I got those factors? All right, now, how are we going to find the zeros from this other factor now, the x squared plus 1? Can I do that again? Sure. So remember, we started with x to the third power. We've done our synthetic division one time, which means that our exponent on what's left at this bottom line is going to be 1 less than that. So this is just 1x squared plus 0x plus 1 now, right? Because the last 0 is the remainder. So that just represents 1x squared plus 0x plus 1. But that's just x squared plus 1, right? Because the 0x goes away. And so that's how I got this x squared plus 1 as my other factor now. And then again, because 3 is a 0, right? That's how we know that x minus 3 has to be one of our factors also. Okay? Any other questions there? All right, now the question is, once we have this x squared plus 1, how would we find the zeros from that factor? So first off, is it going to factor? Can we factor x squared plus 1? We can't, right? It's a sum of squares. It doesn't factor. So we need another way to find the zeros from that factor now. So what can we try? Okay, we could, all right, either one of those is correct, right? We could set it equal to 0, try to solve it, or we could use quadratic formula. Now I'm going to tell you on this one, just setting it equal to 0 and solving is going to be easier because we don't have a middle term, right? If we had a middle term, we'd have to go with quadratic formula. That'd be our only option. Or in this case, I can just take x squared plus 1, set it equal to 0, and I can actually just solve that equation now. So what would be my first step to solve this one? Okay, good. Move the 1 over, so that's going to give us x squared equals -1. And then we're going to do what? Take our square root of both sides. And so when I do that, we're going to have x equals what? Okay, good. So the square root of -1 is I, but we also have to remember what in this case? Plus or minus, right? So don't forget, we have a plus or minus square root of -1. The square root of -1 is I, so we end up with plus or minus I. All right, so now when we're listing out our zeros, that means another 0 is going to be positive I, and our last 0 is going to be negative I. There's our list of all of our zeros. And then this would be our factorization down here at the bottom, x minus 3, x squared plus 1. Now, remember we said that we get this down to a complete linear factorization, meaning that all of our exponents would just be x to the first power. If I were to do that, then this would be x minus 3. What factor would give me I as a 0? X minus I. Okay, and Destry, to answer your question, we don't need I squared of 1 because the square root of 1 is 1, and so that's really just 1I, and so we can just simplify it down to I at that point. Okay, so yes, you could break it down into those steps and say, yeah, bring out the I, keep the square root of 1, but the square root of 1 is 1, and 1I is just I. All right, so now that gives us x minus I as one of those factors. What would the other factor need to be then to give us a positive I, or sorry, a negative I? The x plus I, right? So we're going to do x plus I. So this right here would be the complete factorization now, where all of our x's are to the first power, and all of those numbers now are complex, right? So we have the 3, the I, and the negative I. Those are going to be all of our zeros for that polynomial. Any questions about how we got the zeros or the factorization for this one now? Okay, and again, on a test, right, if plus or minus I, that's perfectly fine. In WebAssign, it's going to make you list them out separately. So you'll have to list it as 3I and negative I, right? So you have to break those up. That's a great question. Okay, so remember when we looked at the graph, the only place that it actually crossed the x-axis was 3, right? Because our graphs only show us real numbers. There's no imaginary values there. And so these aren't actually going to show up on a graph. So whenever you graph these things, right, and you only see 1, 0, and you'll see later as we go that this one has to have 3, then you'll know that the rest of them have to be imaginary, okay? Because in this case, we only have one place where it crosses the x-axis, so everything else has to be imaginary. Those just don't show up on the graph at all, okay? But they're important because that's what tells us that this polynomial is the one that's being graphed now. Any other questions there? All right, I'm going to skip example 2 here because we got another one just like it later. So zeros. Every polynomial of degree n greater than or equal to 1 has exactly n zeros. Okay, so if we look at the degree of a polynomial, that's going to tell us how many zeros we have, provided that a 0 of multiplicity k is counted that many times. Okay, so if you remember back when we talked about multiplicity of our zeros, just make sure that you're counting that 0 that many times. And then as long as you do that, once you add up all of your zeros, it's going to equal whatever the degree is. Okay, so like I said on that previous one we just did, the degree there was 3. That's what told me there should be 3 zeros to that polynomial. So once I found the one real one, I knew there had to be two others, and I knew they had to be imaginary. Okay? All right, so let's take a look at this one now. We want to find the complete factorization and all 5 zeros of this polynomial. And the reason we know there's 5 is because the degree of that polynomial is 5 this time. All right, so what's the first thing we could do here to find the zeros and factor? So we can't complete the square because we don't have a quadratic to begin with, right? So remember, that's the only time we could use completing the square is if it's x squared to start with. All right, so we do have a common factor this time, right? So looking at our numbers here, 3, 24, and 48, those have a 3 in common. And then x to the 5th, x cubed, and x have an x in common. So we can factor out a 3x. Good. If we do that, what's going to be left over then? All right, guys, we'll have x to the 4th. Then we're going to have an 8x squared and a positive 16. So that's our first step. Since we have that common factor, go ahead and factor that out. All right, now let's look at what we've got in the parentheses down there. What could we do with that now? Yeah, so we have two options, right? We could find our P's and Q's, but in this case, we actually have a trinomial that we might be able to just factor into two binomials. So let's see if it factors first, and if it doesn't, then we'll go with our P's and Q's, right? I'm going to keep my 3x out front here, and I'm going to see if I can come up with two binomials that would give us x to the 4th plus 8x squared plus 16. So what would we start with to give us x to the 4th? Good. We can do an x squared and an x squared. That would be x to the 4th. Now we'll look at the constant terms. What can we use for 16? Yeah, 4 and 4 here would give us 16, and it would also give us the 8 that we want in the middle. So we're going to use a positive 4 and a positive 4. So those would be the factors then of that trinomial that we had. So instead of having to use the P's and Q's and do synthetic division, this one actually just factors. Now, once we have those factors, always look to see if it factors any further. Can we factor the x squared plus 4 any more than that? Not yet, right? Okay, so we know we can eventually get it down to linear factors, but we're going to have to find the zeros first to be able to do that because x squared plus 4 is not going to give us anything real as factors now. So how am I going to find my zeros? Okay, good. Set them equal to 0, right? And I'm going to set each factor in this case equal to 0. So we'll have 3x equals 0, x squared plus 4 equals 0, and then the last factor is also x squared plus 4 equals 0. All right, so if we solve this first one, 3x equals 0, what's that going to give us? Zero, right? Because you're just going to divide by 3, and 0 divided by 3 is 0, right? So that's one of our zeros of this polynomial now. Then for this next one, x squared plus 4 equals 0, what's our first step? Move the 4. Good. So I have x squared equals negative 4. Then we can do what? Take the square root. Good. If we take the square root here, what's that going to give us? Good. 2i, and we have to remember what? Plus or minus, right? This is going to give us positive or negative square root of negative 4. And then the square root of negative 4 is going to be a 2i. Because remember, we can bring out the I, and then the square root of 4 is 2. So that's how we get 2i. Any questions about how we got those zeros? All right, and then the x squared plus 4 equals 0 at the end is going to give us what? Same thing, right? Okay, so if we solve this, this is also going to give us x equals plus or minus 2i. All right, so now let's think about the complete factorization with linear factors and all of our zeros here. Let's talk about the zeros first. What are all the zeros of this polynomial now? Okay, good. So we have 0, we have 2i, and we have negative 2i. But wait a minute, we said there should be 5 zeros, and we've only got 3. Why? Okay, good. So in this case, right, the 2i and the negative 2i actually happen twice, right? So they have a multiplicity of 2. So you'd want to say that this one here has a multiplicity of 2, and this one right here also has a multiplicity of 2, and therefore we actually have 2, 4, 5 zeros now, okay, if you actually count them that many times. Now, obviously in WebAssign, you're actually going to have to list them twice, right? So you would list 0, 2i, 2i, negative 2i, negative 2i. Those would be the 5 zeros. On a test, you can either list them twice or just tell me they have a multiplicity of 2 so that I know you understand that they actually add up to whatever the degree is, okay? Any questions about finding the zeros this time? All right, let's do our factors, okay? We know in this case that one of the factors is 3x, right? So make sure that you keep 3x, not just x, as that first factor. What's another factor going to be this time? Okay, good. So we're going to have x minus 2i, because that would give us the positive 2i. What else would have to be a factor here? Okay, x plus 2i, good, because that would give us the negative 2i. Again, we need 5 factors this time because we know our degree is going to be 5. So those x's have to add up to 5, right? So what other factors are we going to have here? Exactly, right? We have 2 options, right? We could list the x minus 2 again and the x plus 2 again, or we could just say, well, this one right here is going to be squared, and this one right here is also going to be squared, right? Because we know the multiplicity of the 2i and the negative 2i should be 2. And so this right here would be our complete factorization for that polynomial. And then this would be our list of zeros. Any questions on finding the zeros or the factorization this time? just so you know, right, if you had gotten to this step right here and you didn't recognize that you could factor it this way, you could use your P's and Q's. The problem there is none of them are going to be real. So when you go to your graph, you're going to recognize, oh no, it never crosses the x-axis, right? The x squared plus 8x squared, or sorry, the x to the fourth plus 8x squared plus 16, never going to cross. You're not going to have anything to test with synthetic division. And so that's why we have to do this when it's factors. We can't actually do synthetic division this time because there's no real ones that are part of that one. All right, so now we're going to work backwards. Okay, so we want to find a polynomial that has a degree of 4, and they tell us the zeros here are I, negative I, 2, and negative 2. And then they give us this P of 3 equals 25. We'll deal with that at the very end. Okay, so the first step is let's figure out, based off of these zeros, what we know about this polynomial. So if they give us the zeros, what do we know for sure? So let's just start with the I here. If I is a 0, what does that tell us about this polynomial? All right, well, we know I is complex, right? It's an imaginary value. Okay, but if we're trying to eventually find the polynomial itself, where might we want to start when we know the zeros of the polynomial? So think about where we ended up on the previous examples. That's where we're going to want to start because then we can work backwards and actually find the polynomial. Yeah, we can write the factors, right? So if I is a 0, then what's one of the factors going to have to be? X minus I, right? So I know that one of my factors now is X minus I because I is a 0. What else has to be a factor? X plus I, because that would give us the negative I. What else needs to be a factor? X minus 2 would give us the positive 2. Our last factor is going to be what? X plus 2. Good. Okay, so now we know the factored form, at least, of that polynomial. And it says it should have a degree of 4 because we have 4 zeros. And here, when we multiply all these x's together, that's going to give us x to the 4th, right? So that's the next step, right? Now we're just going to multiply all this out. Now, always start with your I terms, anything that's imaginary, multiply those together first, because a lot of times the i's will cancel out and you'll get some nice factors that only have real parts. Okay, so I'm going to distribute here. X times x is going to give us x squared. X times positive I is plus xi. Inner terms, negative I times x is going to be a minus xi. And negative I times positive I is negative I squared. So that takes care of multiplying the x minus I times the x plus I. Now I'm going to do the same thing with the x minus 2 and the x plus 2. We have x times x is x squared. Outer terms here give us plus 2x. Inner terms are minus 2x. And then negative 2 times 2 is going to be a negative 4. Now, to simplify this, what would we do next? Okay, good. We can cancel out like terms, right? Because we have xi and negative xi. So I know these terms are going to cancel. And the other one, I have a positive 2x and a negative 2x, so I can cancel those out. What else can we do? right? We can multiply. Now, before we do that, though, is there anything else that I could simplify here? Because we are going to want to multiply all this together, right? So, yeah, this down here is x squared minus 4. I agree with that. What about the first set of parentheses? Is there anything I can do in there first before we multiply? That's right. Remember, the I squared becomes a negative 1. So this factor right here is actually going to be what then? X squared plus 1, right? So not x plus 1 and x minus 1, because that would be if it was x squared minus 1. Because this is a negative 1 and we're subtracting it, this actually becomes x squared plus 1. Okay, so change that I squared to a negative 1. We're subtracting it, so it becomes positive. So we end up with x squared plus 1. And if you think about it, right, if I were to set x squared plus 1 equal to 0, 1 over, and take the square root, I'm going to get that plus or minus I, right? All right, now, we don't want to factor the x squared minus 4 because that's just going to take us back to where we started, right? We're trying to find the polynomial now. So we got to keep moving forward. So what are we going to do now? Now we need to multiply, right? So we're actually going to distribute all this out. So again, it's just going to be FOIL again because I've got two terms and two terms. X squared times x squared is going to give us x to the fourth. Outer terms here would give us a minus 4x squared. Inner terms are going to be plus 1x squared. And our last terms, minus 4. Now it's just a matter of combining like terms here. So what's our final answer going to be for that polynomial? Good. So x to the fourth minus 3x squared minus 4. Now, there's one other thing we have to consider here. They told us that P of 3 needs to be equal to 25. So remember, we said before, we can actually take a polynomial and multiply it by some value without changing the zeros. So what I want to do this time is I'm actually going to set this equal to 25. I'm going to multiply by some a value on the outside. And I'm going to substitute 3 in for my x value. So this is going to be 3 to the fourth minus 3 times 3 squared minus 4. And then I'm going to solve for a so I know what I need to actually multiply my polynomial by this time. So if we simplify this now, what's 3 to the fourth power going to be? That's 81. Good. Then we have a negative 3 times 3 squared. Well, 3 squared is 9. If we multiply 9 times negative 3, what's that going to be? Negative 27. Good. And then we have our minus 4. So now if we combine all of that, what's 81 minus 27 minus 4? Good. That's going to be 50. Then our last step, we need to get a by itself. So I'm going to divide by 50. 25 divided by 50 is going to give us what? 1/2. Good. And so now I know that I have an a value of 1/2. So when I actually write out this polynomial, p of x is going to be equal to 1/2 times x to the fourth minus 3x squared. Sorry. X squared minus 4. And you could distribute the 1/2 also if you wanted to do that and get the 1/2 x to the fourth minus 3/2 x squared and then minus 2, right? That would be fine also. This is how you would find that a value. Plug in the 3 for the x, set it equal to 25, and then just solve for a to see what we actually need to multiply by this. So the reason for that is because they give us this p of 3 equals 25 piece. So we can't just stop at the value we got x to the fourth minus 3x squared minus 4, because that polynomial wouldn't have a value of 25 at x equals 3. So we have to figure out what that a value is going to be so that we know what the exact polynomial is that we're looking for. Okay. Now, if they don't give us that, then we would have just stopped over here on the right-hand side once we got x to the fourth and all that other stuff. Okay. But because they gave us a point on that graph, we have to find the a value now. Does that make sense? Okay. Any other questions there? Yeah, so sometimes they'll only give you the zeros, right? And that's honestly the easier situation, because then you just list the factors, multiply them out, and you're done. Okay, but if they give you more information, like a point on the graph, then you have to figure out an a value to figure out what to multiply the polynomial by. All right. Let's take a look at this next one now. So q of x has a degree of 4, and its zeros are -2 and 0. And then they tell us that -2 has a multiplicity of 3. How are we going to start this one now? Good. So what are the factors going to be this time? Okay, good. So we're going to have an x plus 2. And we know it has a multiplicity of 3, so that's going to be to the third power. And then what factor would give us 0? Just x, right? So we're going to have an x now as one of our factors. Okay, so we have a factor of x, and then we have 3 factors of x plus 2 now. Now, we need to actually multiply this out, right, to get the polynomial itself. So when I do that, I'm actually going to write this as x times x plus 2 times x plus 2 times x plus 2, right? Because that's what we're actually multiplying now. Now, it's kind of up to you which order you want to multiply these things in. I'm going to first distribute the x here into that first set of parentheses, and I'm going to multiply the other two together. So if I do that, I've got x times x is going to give us x squared. X times 2 is plus 2x. And now I'm going to multiply the x plus 2's down here together. That's going to give us x squared. Outer terms plus 2x. Inner terms plus 2x. And last terms plus 4. And then we can combine like terms. So we have 2x and 2x is 4x. Now I'm up to x squared plus 2x times x squared plus 4x plus 4. Any questions about how I got up to that point? All right, now here we need to actually multiply these two things out, right? So if you just want to distribute, that's fine. I'm going to do the box method just so we make sure we hit all of our terms. I'm going to create a box here. 2 terms this way, 3 terms this way. Up here I've got x squared positive 4x, positive 4. Down the side, I'm going to have x squared and positive 2x. All right, so now let's fill in our boxes here. X squared times x squared is going to be x to the 4th. X squared times 4x, 4x to the 3rd. X squared times 4, 4x squared. And then we go down to our next line. 2x times x squared should be 2x to the 3rd. 2x times 4x should give us 8x squared. And finally, 2x times 4 should be 8x. Any questions about how I got any of those terms now? All right, now it's just a matter of combining like terms. So I notice I've got some x cubed terms here I can combine, some x squared terms down there I can combine. So once I put all of this together now, what should my final answer be for this polynomial? Good, so x to the 4th plus 6x cubed plus 12x squared, and then we have our plus 8x. This time they didn't give us any additional information, right? No points or anything, so we don't have to find an a value. This time we can stop right there. Any questions on any of the steps for that one now? All right. So example 5, we want to find all 4 zeros of this polynomial. All right, so if we look at this one, we don't have any common factors this time, right? Because there's nothing in common with all of our terms. No x's we can factor out or anything like that. So what do you think we're going to want to do first here? Okay, so before we graph, right, what could we find first? Because I agree, we are going to go to the graph event. Yeah, let's find our P and Q values so we know which ones might work, right? Then we'll look at the graph to see which ones of those actually show up on the graph. So if we do that here, values of P this time are going to be what? Good. So 1, 2, and 4, right? So we have plus or minus 1, plus or minus 2, plus or minus 4. Those are the factors of 4. And then for the Q value, we're going to get what? Okay, so 1 and 3, right? So plus or minus 1 and plus or minus 3 this time. Okay, so our leading coefficients of 3, only factors of 3 are 1 and 3. All right, then we can divide, right? So we're going to do P over Q. So if we divide all of those P values by each of the Q values, what's that list going to look like? Good, right? So we're going to have plus or minus 1, plus or minus 2, and plus or minus 4. That's dividing each one by 1. And then when we divide each one of those by 3, we'll get plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. So I don't want to test all 12 of those values, right? So now we can go to our graph, see which ones we might want to test. Let's look at our graph in Desmos. So we've got 3x to the 4th minus 2x cubed minus x squared minus 12x minus 4. And again, I'm not going to actually click on those points. I'm just going to eyeball it and see which ones of these we might want to test, right? So looking at that graph now, what values from our list might we want to test? Okay, good. So 2 looks like a sure shot, right? So 2 should be fine. And it looks like maybe negative 1/3, right? Because we're somewhere between 0 and -1, and negative 1/3 is on our list. Is there anything else on our list that could potentially fall in that range? Negative 2/3 is another possibility, right? So just keep that in mind. Again, because especially on your calculator, if you're not looking at Desmos, all you kind of know for sure is you're between 0 and -1. It looks like we're closer to 0, right? So it's probably going to be the negative 1/3 if either one of them works. Okay, but just know that negative 2/3 is also between 0 and -1. So on your calculator, it might be difficult to distinguish between those two. Okay. All right. So I've got a list of possibilities now. Let's go back and test these using synthetic division. All right. So I'm going to start with the 2, right, because that's a whole number. It's a lot easier to test than the fractions. So we'll go with 2 first. I'll look at my coefficients. I'm not missing any terms this time. So we'll have 3, -2, -1, -12, -4. First step, as always, bring down the first term. So bring down the 3. Now we multiply. 3 times 2 should give us 6. We add. -2 plus 6 is 4. 4 times 2 is 8. -1 plus 8 is 7. 7 times 2 is 14. -12 plus 14 is positive 2. 2 times 2 is 4. And we do get a remainder of 0. Okay. So now in terms of my actual zeros, we know that 2 is one of those zeros. All right, now, what do you want to test next? Okay, let's go with the negative 1/3. All right. And I can continue on from this list here, right? I don't need to go back to my original. Bring down the 3. 3 times negative 1/3 is going to give us a -1. 4 plus -1 is 3. 3 times negative 1/3 again is -1. 7 plus -1 is 6. And 6 times negative 1/3 is going to give us a -2. 2 plus -2 is indeed 0. And so that one checks out, and negative 1/3 is one of our zeros. Right, now, those are the only 2 places it looked like it crossed, right? So what are we going to do at this point? Because we know there should be 4 total zeros. Okay, so let's look at what we've got so far. So what are the factors we know so far? All right, so we know x minus 2. And we know x plus 1/3. And then this line down here gives us what? know we're out of time, so I just want to get these factors, and then we'll probably have to finish this up next week. Okay, we're going to have 3x squared plus 3x plus 6 as a factor. Now, if that thing factored, then we'd be good to go, right? We'd factor it out, we'd set each factor equal to 0, and we'd be done. The problem here is we know for sure it doesn't cross the x-axis anywhere else. You're not going to have any factors that work here. So what would we have to do at this point to find our last two zeros? Quadratic formula or completing the square would work too, right? Okay, so I'm going to go with quadratic formula on this one. I'm going to write it out. I'm not going to finish it, okay, but just so you know, if you wanted to finish this one, it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so this is how we would find those last two zeros, and they will be imaginary, right? So if you want to finish that one out, and I'll go ahead and tell you what they are, just in case you do that. So this would actually give us negative 1/2 plus square root of 7 over 2i, and negative 1/2 minus square root of 7 over 2i. Right, so once you actually solve that, those are the zeros you should get, okay? We'll stop there for today. I'll come back and rework through the quadratic formula next week just to make sure we know how to get those, and then we'll finish up this section. Okay, so you should be able to start some of that homework from 3.5 to 3.7. Let me know if you've got any questions. We'll finish this up next week. And then again, keep in mind that the test will probably be towards the end of next week, and if not, as soon as we get back from spring break. Okay, have a great weekend, and I will see you all next week.